Hi there! In this video we are going to sum up what we learned about machine learning monitoring architectures. We are going to explore factors which influence our choice of particular machine learning monitoring backend. Let us start from a small recap. What are alternative backend architectures? Luckily, we have a lot of options here. We can build machine learning monitoring using ad-hoc reporting, using batch machine learning monitoring, and even using near real-time monitoring architecture. Let's explore those options one by one. And we start from the ad-hoc reporting system. It might be a good solution if you do not have any alternative monitoring systems operated in your company. You just deployed a batch machine learning system and you need to keep an eye and generate your expectations about data quality and models quality. This is a fairly simple approach because you might use any tool you used to write a script. For instance, it can be Jupyter Notebook, Python script, R script, or whatever you're familiar with. The pros are that it's very low engineering overhead, right? Because you just need to implement the script and run it when you need it, right? And this is a good solution to explore and shape your expectations about the model's quality, data drift, and any other properties of your machine learning system, right? However, there are quite a lot of cons. First of all, it's just a reactive analytics. It's not a proper monitoring. And here I mean that you cannot simply build the machine learning-based service and rely on ad hoc reporting instead of monitoring. It just isn't gonna work like that. You will have a lot of issues which you miss, right? And it's not really a reliable approach. In the long term, you will have a lot of issues with reliability, reproducibility, standardization, and even collaboration. So it makes sense to use this approach when you have no other options and very limited resources, but you already want to explore the quality of your machine learning service, but it's not gonna long last, right? And let us move to the second option, which is batch monitoring. This is a great, reliable, and stable approach. In order to implement this batch monitoring, it's essential to have a workflow orchestration tool, like maybe Airflow or Kubeflow, and the tool to calculate for you metrics and tests like Evidently. There are quite a lot of pros of such approach, because it works good enough for both machine learning models implemented as the batch pipelines or machine learning services, right? One can even say that it's much easier to run monitoring jobs compared to operation as a service, but that's questionable, I would say. In case you already have a workflow orchestrator maintained in your company, it's fairly simple, right? Because in this case, you would need to implement your monitoring jobs and have them run under this workflow orchestrator. But in case you do not have any orchestrator in your company, first you would need to maintain this workflow orchestrator, which is the huge service by itself, right? And only after have your pipelines to be operated under this workflow server. In this case, it might be even easier to build the standalone monitoring service for your machine learning models. So it's always important to understand what your options are and come up with the solution which suits you most. However, there are quite a lot of advantages of such approach. And first of all, it's quite flexible. If you have some pipelines to be run during the experimental phase of your machine learning model lifecycle, and some pipelines for the validation phase where you already have your model operated in production, you can have all those pipelines to be operated under your workflow manager. And it's quite convenient when, for example, you already have automatic retraining of your model, right? And for retraining, you have some pipelines. For just model monitoring, you have the other pipelines. You can have all those pipelines under your workflow orchestrator, which is quite convenient, right? And you can combine different type of metrics. If you have some metrics which can be calculated in an immediate manner, like data quality or data integrity metrics, you can have them run by schedule, like every 10 minutes, every 10 seconds, whatever. But if together with such pipelines, you have some pipelines which depend on your ground truth and you have your ground truth delayed, in this case, you can implement the calculation of such pipelines by trigger, like as soon as you have this new labeled data, after this event, you run this metrics calculation, right? And it's quite flexible because you can combine all those pipelines and build up a single dashboard using the metrics from the metric source, right? Just make sure that you scheduled those pipelines accordingly. I mean that data quality and data integrity pipelines are operated and calculated by schedule, and the data quality metrics, for example, which depends on the delayed feedback, calculated by trigger. And in this case, trigger is the event when you received the new labeled data. That's very flexible. However, there are some cons of such architecture as well. First of all, anyway, you will have some delay in metrics computation just because of extra resources you spent to support your workflow architecture. I mean computational resources and networking maybe, if you have a distributed system, right? And also, in order to implement that, you will need to have some familiarity with the workflow architectures, right? And some data engineering resources to support the initial system. But generally, this is the very reliable and stable approach, which you can use for both pipelines, model, and machine learning services. And finally, let us discuss near real-time or streaming monitoring. If you prefer this approach, you would need to care about the optimal way to store your time series data, so you will need to have the tools like Prometheus or maybe ClickHouse in order to store your data efficiently, and the tools like Grafana or Evidently for dashboarding and alerting. In this case, you will be able to detect any real-time or near real-time issues related with your machine learning services, and this works very well for model cert as an API because you can directly send your data from your machine learning service to the monitoring service, so it will be really fast, sometimes even near real-time or real-time. If you know for sure that you have quite a lot of near real-time issues to detect and immediately react, like maybe missing data or some outliers which you want to send to a manual review, for instance, this is a great approach for you. But it's very important to realize that such architecture needs the higher operation costs, right? Because it's another service to run and maintain. And sometimes it might lead to a double effort because typically quite often you have to deal with the delayed feedback, and in this case anyway you would need to implement some monitoring jobs in a batch mode to calculate some metrics after you received new batch of data and send them to the same monitoring system. So the conclusion is, this is the great approach, use it when it's necessary and if you have resources to support it. So it's important to make sure that you are able to support such system. Finally, I would like to mention that you always can build up a custom monitoring backend solution, right? For instance, you can combine the near real-time and batch monitoring approach all together. Let's say you have quite a lot of issues to detect in near real-time. In this case, it makes sense to send your data directly from the machine learning service to a monitoring service, calculate things like input data checks or maybe model output checks as well, log those data into metric storage, and use your dashboarding system with those metric storage so that you can see all the panels and alerts in real time. Together with that, if you deal with delayed feedback, you can have some monitoring jobs which calculate your quality checks, I mean model quality checks, as soon as you got those labeled data. And in this case, you can also log this data to the same metric storage and use those data as the source to your monitoring dashboard. So you'll have a single monitoring dashboard which includes some panels with the batch jobs and panels from the real-time monitoring system, which can be exactly what you need, right? So here I mean that you can always build something custom, taking into account all the options and all the resources you have. So what risks there are, how much engineering resources you have, what type of metrics you want to calculate. Take all those factors into account and decide on the optimal monitoring backend for your system. Let me briefly bring up a case for batch monitoring so that you can track the logic we use behind choosing the right machine learning backend architecture. First of all, I would like to start from the traditional software monitoring because this is something that we always have when we have production service, right? The traditional software monitoring looks somewhat like here. In this case, you can implement additional endpoint like a metric so that you can use the system which will pull the metrics from your service. You can use Prometheus, for instance, as the system because it's very well designed for storing time series based data, especially with high frequency, right? And you can easily pull those data from the matrix endpoint, store it, and Prometheus even calculate some alerts and use some dashboarding tool which will use this Prometheus data as the data source so that you can easily access the dashboard and see any panels related to service health. This is a great architecture, so it's very widely used, and I believe the first idea which comes to our mind for building machine learning service monitoring is to just add a couple of machine learning related metrics to the same endpoint and then reuse all the next tools of our monitoring system. I mean, just calculate those machine learning metrics, add it to very same metrics endpoint, then pull those metrics together with the service health metrics with Prometheus, and just add a couple more panels to your dashboarding tools, right? The idea sounds very attractive. However, there are some issues with metrics related to machine learning which needs to be taken into account. So let us start from the software metrics. Generally, there are pretty simple metrics in terms of the calculation, not in terms of meaning. Here I mean that when you calculate service health metrics, what you generally do is just to derive some parameters, some data from the response, like the response time, right? Or memory used, and then you don't perform any complex calculation. You just do pretty straightforward aggregation over the derived values. So that's how you calculate most of the software metrics. But when it comes to machine learning metrics, it's not just a simple aggregation, right? Because quite often we need to have some additional data, or we need to complex pretty long calculations like statistical tests, etc. And often we need to have additional data to our responses, for instance, ground truth. So we cannot really implement it in the very same way by just deriving data from our responses and just aggregate over those data. Let us take a closer look to some complexities here. Quite often for machine learning related monitoring, we need to calculate very different metrics, like data quality and data integrity metrics and model performance metric. As for about data quality and data integrity, quite a lot of such metrics are fairly easy to calculate. Those are metrics like number of rows, number of columns, share of missing values, etc. So those metrics can be implemented very similarly to the service health metrics. But when it comes to model performance, it's a little bit trickier. Let's say you need to calculate some model performance metrics like precision or recall, but you have delayed feedback. If you have delayed feedback, you cannot calculate it straightforwardly, so that's the first problem. We already need to wait until we get those labeled data so that we are able to calculate these metrics. After we calculated these metrics, we need to perform so-called backfill with time serials, because the moment when we received those labels and were able to finally calculate quality metrics is not the same moment we want to log this metric, right? So we want to log these metrics with the time series equals to the moment when we receive those responses, right? Not the moment when we receive the labeled data. And this is why we need to do some backfilling. So if our delay is equal to, let's say, 1 day, then we want to do a backfill with the day horizon, right? That's quite important to understand. Second issue is the reference dataset. Because to calculate metrics like drift, especially if you use two-sample statistical tests or distance metrics or model-based approach, you need not just have this data from the current batch, right? You also need to pass somehow the reference data set to be able to calculate those metrics. So it doesn't easily fit to a traditional software monitoring architecture. All those issues lead us to the resolution, which is rarely automatic. Quite often we need to add the additional components to our initial service health architecture. Let me quickly show what I mean here. The solution to complex metrics is to have a metrics calculation pipelines. In this case, you will be able to use an appropriate backend without any limitations to calculation types. Here I mean that you do not necessarily need to implement your metrics calculation in a SQL query, right? You can use any appropriate backend which is supported by your orchestrators. You also can have any complex evaluations like statistical distribution drift, behavioral tests that cannot be simply measured in time. In this case, if you have a pipelines to calculate those metrics, you can use any additional libraries which will be installed to the place from where you run those pipelines and calculate any metrics, which is very convenient. Also, we have a solution for ground truth issues. In this case, if you have some metrics which doesn't depend on your ground truth and some metrics which does depend on your ground truth, you can basically split them into separate pipelines. So the pipelines which doesn't need any delayed data can be calculated and run in a schedule like every 10 seconds or whatever makes sense for your system. And the pipelines which need some delayed data can be calculated on a trigger, and the trigger event would be you just received new labels. The solution for reference dataset issue is quite interesting as well and also related to pipelines. So the idea here is that you can build pretty complex pipeline which consists from several steps. The first step will be to get new data, then to get the reference data, right? And only after the first two steps were successfully complete, you can run the drift test calculation, right? And finally log the scores to your metric storage. Well, if we imagine the whole cycle of operation of our batch model, we can cover it by these batch pipelines. I mean, let's say that we just received a new batch of data. In this case, we might run data quality and data stability checks. After those checks pass, we can score our new data. And after we scored the data, I mean we generated the model's output, we can check model prediction drift. Then we can wait until we receive the labeled data, and as soon as we get our new labels, we can calculate the model's quality and run a couple of model quality checks. If we detect some model's quality issues, let's say we see the significant quality drop, we can retrain our model, for instance, and check the new model's quality. And if we are happy, we deploy this new model. Then again, we receive the new batch of data and we repeat the cycle. Of course, it's a very simplified cycle, and before we discussed the strategies for model retraining as well, which are not that straightforward, right? But I believe you got the idea. So let us come back to the architecture question, because we started from the idea that we actually want to take the existing traditional software monitoring and add up a way to calculate machine learning related metrics. Well, it can be done, but we need to integrate to our traditional software monitoring the additional step, which will help us to run some pipeline jobs where we need to run them. So the idea is that when you have your software service, which receives some requests and returns some responses, you can also implement the prediction logging system. But I believe it's already implemented for most cases, because that's essential part of production services. So basically, you can use those prediction logs, but make sure that you log all the needed data there. We also discussed it before. Well, yes, you can use these prediction logs as the source for your pipeline and monitoring jobs. In this case, you can read the data from those prediction logs and add any additional data you need, like reference data or maybe ground truth data. Then you implement and run any jobs you want, so it can be data related to drift, which uses the reference data. It can be model quality metrics, which uses the ground truth data, etc., and just feed and store those data to the metric storage. The final step will be have the dashboarding system, which uses this metric storage as the source data, and it can be the same dashboarding tool which you already use for the service health monitoring, or if you prefer to, you can build up for yourself additional dashboard which will be only focused on the monitoring metrics. It's always up to you. To sum up, I would say that it's essential to match the machine learning monitoring architecture with the resources you have, the risks you're trying to mitigate, and the machine learning model complexity, right? Even if your model is deployed as the machine learning service, you can consider batch monitoring if that's what you prefer to have, right? It's more lightweight architecture, especially if you already have the workflow orchestrator implemented and supported in your company. And it allows you to incorporate pretty complex evaluation scenarios, which is hard to reduce to a single metric and implement, let's say, as a SQL query.